Now let us try to follow a model on Stephen's law. The model says the rate of radiation from a black body at 0 degrees Celsius is E. The rate of radiation from the black body when its temperature is 273 degrees Celsius is. Okay. For 0 degrees Celsius, 0 degrees Celsius kaite Kelvin scale lo ఉష్ణోగ్రత వచ్చేసి 273 కెల్విన్ అవుతుంది. అదే మాదిరిగా 273 డిగ్రీ సెల్సియస్ దగ్గర ఉష్ణోగ్రత కెల్విన్ స్కేల్లో 273 ప్లస్ 273 కెల్విన్ అవుతుంది, అనగా 2 టైమ్స్ ఆఫ్ 273 అవుతుంది. స్టీఫన్స్ నియమం నుండి E is equals to sigma t power 4, అనగా E1 by E2 is equals to T1 by T2 whole to the power of 4. E1 స్థానంలో ఈని ప్రతిక్షేపించి E2 అలాగే రాసేసి T1 273గా రాసి T2ని 273 ఇంటూ 2గా రాసి హోల్ టు ద పవర్ ఆఫ్ 4 రాసినట్లయితే E by E2 is equal to 1 by 2 whole to the power of 4 అవుతుంది. దానివలన E2 is equal to 16E అవుతుంది. అయినా మీ యొక్క సమాధానం వచ్చేసి మూడవది. Now let us take another model on Stephen's law. What it says is, two spheres have radii 1 meter and 2 meters. రెండు గోళాల యొక్క వ్యాసార్థాలు 1 మీటర్ మరియు 2 మీటర్లుగా ఉంది. Are at same temperatures having emissivities E and 2E, then the ratio of radiant energy emitted per second is. ఇక్కడ ఒక సెకండ్ కాలంలో ఉద్గారమైనటువంటి వికిరణ శక్తి గురించి అడుగుతున్నాడు ఈ ప్రాబ్లంలో. దానికోసమని మనము E by AT is equal to sigma t power 4గా తీసుకుందాము. ఇది కేవలం బ్లాక్ బాడీకి. అలా కాకుండా ఇతర బాడీలకైతే ఇతర వస్తువులకైతే E by AT is equal to sigma E into t power 4 అవుతుంది. దీని నుండి E proportional to R square into E, అనగా E1 by E2 is equals to R1 by R2 whole square into E1 by E2. E1 by E2 is equal to R1 by R2 వచ్చేసి 1 by 2 whole square into E by 2E. So E1 by E2 is equals to 1 by 4 into 1 by 2, it is equal to 1 by 8. అనగా E1 is to E2 is equals to 1 is to 8. మీకు సమాధానం మూడవది. స్టీఫెన్ నియమంలో మరి ఒక లెక్క తీసుకుందాము. ద రేట్స్ ఆఫ్ హీట్ రేడియేషన్ ఫ్రమ్ టూ ప్యాచెస్ ఆఫ్ స్కిన్ ఈచ్ ఆఫ్ ఏరియా A ఆన్ ఏ పేషెంట్స్ చెస్ట్ డిఫర్ బై 2%. If the patch of lower temperature is at 300 Kelvin and emissivity is given as 1 for both the patches, the temperature of other patch would be. ఇక్కడ స్టీఫెన్ నియమం నుండి మనకు వచ్చినటువంటి సమీకరణం E/AT is equals to సిగ్మా T⁴ గా వస్తుంది. E/T is equals to power equals to sigma A T⁴. దీని నుండి పవర్ T⁴కి అనులోమానుపాతంలో ఉంటుంది. P proportional to T⁴ని మనము dP/P into 100 is equals to 4 into delta T/T into 100గా రాసుకోవచ్చు. ఇక్కడ డెల్టా P/P ఇంటూ 100ని మనకు లెక్కలో 2 అని ఇచ్చారు. 2 ఈజ్ ఈక్వల్స్ టు 4 ఇంటూ డెల్టా T వచ్చేసి 300 ఇచ్చారు ఇంటూ 100. టూ ఈజ్ ఈక్వల్స్ టు 4 ఇంటూ T2 మైనస్ T1 బై 3గా రాసుకోవచ్చు. ఇక్కడ మనకి 6/4 ఈక్వల్స్ టు T2 మైనస్ 300. T2 ఈజ్ ఈక్వల్ టు 300 ప్లస్ 6/4, 300 ప్లస్ 3/2 1.5గా రాసుకోవచ్చు. దీనికి మనకు వచ్చిన ఆన్సర్ 301.5 కెల్విన్గా వచ్చును. అనగా మీది సమాధానం 4వ ఆప్షన్, 4th ఆప్షన్. స్టీఫెన్ నియమంలో మరొక లెక్క తీసుకుందాము. A sphere and a cube of same material and same volume are heated up to same temperature and allowed to cool in the same surroundings. The ratio of the amounts of radiations emitted will be 1:1, 4π/3:1, π/6 whole to the power of 1/3:1, half into 4π/3 whole to the power of 2/3:1. First of all, లెక్కలో మనకి వాటి వాల్యూమ్స్ సమానంగా చెప్పారు. కావున వాల్యూమ్ ఆఫ్ స్పియర్ ఈక్వల్ టు వాల్యూమ్ ఆఫ్ క్యూబ్, అనగా 4/3 πr³ ఈజ్ ఈక్వల్స్ టు ఏ క్యూబ్. దీని నుంచి R/A whole to the power of R/A whole cube is equals to 3/4 into 1/π అవుతుంది. R/A ఈక్వల్స్ టు 3/4π whole to the power of 1/3 అవుతుంది. స్టీఫెన్ నియమం నుండి E/AT is equals to E into sigma T⁴ minus TS⁴గా సూత్రం. అందుకోసం పవర్ ఈక్వల్స్ టు EA sigma TB⁴ minus TS⁴ implies P proportional to A², అనగా P1/P2 is equals to A1/A2 whole square is equals to A1/A2 whole square. దీన్ని మనము 4πr²/6a² రాసుకోవచ్చు. ఇక్కడ 4π/6 ఇంటూ R/A whole squareగా రాసినట్లయితే 4π/6 ఇంటూ 3/4π whole to the power of 2/3గా వస్తుంది. దీన్ని సూక్ష్మీకరిస్తే మీకు వచ్చినటువంటి సమాధానం π/6 whole to the power of 1/3:1 వస్తుంది. స్టీఫెన్ నియమం తర్వాత నెక్స్ట్ మనం తీసుకోబోయే నియమం వచ్చేసి న్యూటన్స్ లా ఆఫ్ కూలింగ్ ఎఫెక్ట్. ఈ నియమం ప్రకారం ద రేట్ ఆఫ్ హీట్ లాస్ట్ బై ఎ బాడీ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు డిఫరెన్స్ ఆఫ్ టెంపరేచర్స్ ఆఫ్ బాడీ విత్ సరౌండింగ్ టెంపరేచర్. అనగా dQ/dt ప్రపోర్షనల్ టు TB మైనస్ TS. dQ/dtని మనము ms dθ/dt ఈజ్ ఈక్వల్స్ టు K ఇంటూ TB మైనస్ TSగా రాసుకుంటాం. ఇక్కడ రేట్ ఆఫ్ హీట్ లాస్ట్ అనేది ఉష్ణం నష్టపోతుంది కాబట్టి ఇక్కడ నెగటివ్ సైన్ అనేది ఏర్పడుతుంది. దానికోసమని మైనస్ dθ/dt ఈజ్ ఈక్వల్స్ టు K/ms ఇంటూ TB మైనస్ TSగా ఏర్పడుతుంది. కావున dθ/dt ఈజ్ ఈక్వల్స్ టు మైనస్ B ఇంటూ TB మైనస్ TSగా రాసుకుంటాం. Now let us take the model on Newton's law of cooling effect. A body at 50 degrees Celsius cools in a surroundings maintained at 30 degrees Celsius. The temperature at which the rate of cooling is half that of the beginning is. The options here are 16.32 degrees Celsius, 26.3 degrees Celsius, 40 degrees Celsius and 46.3 degrees Celsius. Now the problem here is relating with Newton's law of cooling effect. So what we can write is actually dθ/dt is proportional to TB minus TS. Rate of decrease in temperature, the rate of change in temperature is proportional to difference of temperature of body to the temperature of surroundings. Okay, so here rate of change of temperature is taken as R proportional to TB minus TS. So I can write this as R1 by R2 is equals to TB minus TS1 by TB minus TS2. Now substituting the values of R1 and R2. R1 is given as R, R2 is given as R by 2 is equals to 50 minus 30 by theta minus 30. From this we have got 2 equal to 20 by theta minus 30. Theta minus 30 is equals to 20 by 2. So theta equal to 40 degrees Celsius. Now let us take another problem on Newton's law of cooling effect. A body cools from 50 degrees Celsius to 45 degrees Celsius in 5 minutes and to 40 degrees Celsius in another 8 minutes. The temperature of the surrounding is, the options given for us are 34 degrees Celsius, 30 degrees Celsius, 43 degrees Celsius and 37 degrees Celsius. Okay. Now, according to Newton's law of cooling effect, what we have got is d theta by dt is proportional to Tb minus Ts. Okay. From 50 to 45, okay, we have time 5 minutes, so that 5 by 5 minutes is equals to k into 50 plus 45 by 2 minus theta naught, 1 equal to k into 95 by 2 minus theta naught. Similarly, 45 to 40 degrees Celsius in time 8 minutes is given as 5 by 8 is equals to k into 45 plus 40 by 2 minus theta naught. 5 by 8 is equals to k into 95 by 2 minus theta naught. ఈ రెండు సమీకరణాలను ఒకదాని ఒకటి భాగించగా 1 by 5 by 8 is equals to 95 by 2 minus theta naught divided by 85 by 2 minus theta naught. దీన్ని సూక్ష్మీకరించగా theta naught equal to 34 degrees Celsius గా ఏర్పడును. ఇంతకుముందు చేసినటువంటి ప్రాబ్లం తోటి మనకు ట్రాన్స్మిషన్ ఆఫ్ హీట్ అనే లెసన్ అయిపోయింది. ఇప్పుడు మనం నెక్స్ట్ లెసన్, అది కెలోరీమెట్రీ అనే లెసన్కి వెళ్తున్నాము. కెలోరీమెట్రీ. Calorimetry means measurement of heat. A device which is used to measure heat is a calorimeter. It works on the principle of method of mixtures. Principle of method of mixtures. It states that when two non-reactive substances are mixed, the heat gained by cold substance is equal to heat lost by hot substance. The heat required to warm a substance or a body depends on its mass and change in temperature. According to this, delta Q is directly proportional to mass. More is the amount of mass in the body, more is the heat required to warm it up. Similarly, it is also proportional to delta theta. When you supply more amount of heat, there will be more difference in temperatures. Combining these two, we have got delta theta is equals to delta Q is equals to m into retake from here onwards. Delta Q is proportional to m into delta theta. Delta Q is equals to k into m delta theta. Here k is taken as S and is called as specific heat. So delta Q is equals to m into S into delta theta, where S is equals to 1 by m delta Q by delta theta. When heat changes and temperature changes are very, very small, then specific heat is given as 1 by m into dq by dt. Its units are joule per kg per Kelvin or calorie per gram per degree Celsius. Its dimensional formula is L square T power minus 2 theta inverse. Molar specific heat. The amount of heat required to raise the temperature of one mole of a substance through 1 degree Celsius is called molar specific heat. It is given by C is equals to 1 by n dq by dt. Units are joule per mole per degree per Kelvin. If specific heat varies with temperature, then dq is equals to ms d theta. Here q is given as m into integration of s d theta. In liquids, water is having maximum specific heat, whereas mercury is having minimum specific heat. out of all substances of all states, hydrogen has maximum specific heat, radon and actinium has minimum specific heat. Heat capacity or thermal capacity. The amount of heat required to raise the temperature of a substance through 1 degree Celsius is called thermal or heat capacity. Let the substance is given in this form. To increase the temperature of substance by dt, the heat required is dq. Then for 1 degree Celsius, how much heat is required? For that, dq raises the temperature by dt, then x raises the temperature by 1 degree Celsius, implies x dt is equals to dq, or x is equal to dq by dt. This x is called h. H stands for thermal or heat capacity, given as h is equals to dq by dt. dq by dt is also equal to ms. So h is equals to ms is the formula for finding the heat capacity or thermal capacity. Consider the formula h is equal to ms. Mass can be given as volume into density, so that h is equals to VDS. Thermal capacity per unit volume is given as density into specific heat. Next, we will try to understand regarding water equivalent. The mass of water that has same thermal capacity as that of a substance is called water equivalent. Given as mass of water into specific heat of water is equals to mass of substance into specific heat of substance. a lead piece of mass 25 grams gives out 1200 calories of heat when it is cooled from 90 degrees Celsius to 10 degrees Celsius. Then determine the specific heat, thermal capacity and water equivalent of the given substance. The options given are the first one 252063 and 15. The second option is 2000, 60 and 10. Third option is 3000, 70, 20 and fourth option is 3075, 73 and 25. First, given mass equals to 25 grams. 25 grams can be given as 25 into 10 to the power of minus 3 kg. 1200 calorie can be given as 1200 into 4.2 joules. Difference in temperature delta theta is given as 90 minus 10, that is 80 degrees Celsius. At first, we require specific heat. Specific heat S is equal to 1 by m dq by dt. Substituting the values, 1 by 25 into 10 power minus 3 into 1200 into 4.2 joules divided by 80. On simplifying this, we get a value of 2520 joule per kg per Kelvin. Similarly, when we try to find out the thermal capacity H is equals to mass of body into specific heat, and mass of body is given as 25 by 1000. Specific heat is given as 2520. On simplifying this, we obtain a value as 63, whereas water equivalent is given as mass of water is equals to mass of substance into specific heat of substance divided by specific heat of water is equals to 63 by 4200. The value is obtained as 15 grams. Now let us try another model on specific heat when specific heat is varying with temperature. Okay, fine. The specific heat of a substance varies as 3 theta square plus theta into 10 power minus 3 calorie per gram per degree Celsius. The amount of heat required to raise the temperature of 1 kg of substance from 10 degrees Celsius to 20 degrees Celsius is, the options given for us are 7150 calories, 7250 calories, 7350 calories, 7450 calories. Okay. Now, for small change in the temperature d theta, for small change in temperature d theta, the heat required is dq is equals to ms into d theta. dq is equals to m is 1000 kg, 1000 gram. Specific heat is given as 3 theta square plus theta into 10 power minus 3, and change in temperature is to be required. So integrating on both sides, dq is equals to 3 theta square plus theta d theta, integrating from 10 to 20, q is equals to 3 into theta cube by 3 plus theta square by 2 from 10 to 20. On simplifying this, we get q is equals to 7150 calories. Now let us try to do a problem on water equivalent. The water equivalent of copper block of mass 200 grams is, whereas specific heat of copper is given as 0.09 calorie per gram per degree Celsius. We know very well that water equivalent MSW is equals to MS into ESS, that is mass of water into specific heat of water is equals to mass of substance into specific heat of substance. Mass of water is equals to MSSS by SW. In CGS system, MS is given as CGS పద్ధతిలో MS ని 200 గ్రాములుగా ఇచ్చారు, విశిష్టోష్ణాన్ని 0.09గా ఇచ్చారు. నీటికి విశిష్టోష్ణం 1 కావున నేరుగా మనకి 18 గ్రాములు అని ఏర్పడింది. థర్మల్ కెపాసిటీ మీద మరొక ప్రాబ్లం చేద్దాము. 2 spheres of radii in the ratio 1:2 have specific heats in the ratio 2:3. The densities are in the ratio 3:4. The ratio of their thermal capacities is. The thermal capacity H is given as mass into specific heat, where mass is given as volume into density into S. From this what we have got is H1 by H2 is equals to V1 by V2 into D1 by D2 into S1 by S2. The volumes are the volumes of the spheres. So volumes of spheres is proportional, volume of sphere is proportional to radius cube. Therefore we can write it as R1 cube by R2 cube into D1 by D2 into S1 by S2. Accordingly what we have got is 1 by 2 whole cube into 3 by 4 into 2 by 3. On simplifying this we get it as 1 by 16. Now let us do a model on specific heat. The temperature of equal masses of 3 different liquids A, B and C are 12 degrees Celsius, 19 degrees Celsius and 28 degrees Celsius respectively. The common temperature when A and B are mixed is 16 degrees Celsius. When B and C are mixed is 23 degrees Celsius. The common temperature when A and C are mixed is. In this problem you are given equal masses. Whenever you are given equal masses, in such case what you can do is you can take a specific heat is inversely proportional to change in temperature, S proportional to 1 by delta theta, so that you can write it as SA by SB equals to delta theta B by delta theta A. Similarly SB by SC is equals to delta theta B by delta theta C. What we require here is actually we require the common temperature of A and C. For that purpose we need SA and SC. For that we need SA and SC. Okay. Now SA by SB can be written as 19 minus 16 by 16 minus 12, which is equal to 3 by 4, from which we are getting SA by SB equal to 3 by 4. So SB equal to 4 SA by 3. Alage SB by SC is equal to 28 minus 23 by 23 minus 19. It is equal to 5 by 4. So SB equal to 5 by 4 SC. ఈ 1-2 సమీకరణాల నుండి 4 SA by 3 is equal to 5 SC by 4. దాని నుంచి మనకి SA by SC equal to 15 by 16 వస్తుంది. దాంతో డెల్టా తీటా C by డెల్టా తీటా A equal to 15 by 16. డెల్టా తీటా Cని 28 మైనస్ తీటాగా రాసుకొని డెల్టా తీటా Aని తీటా మైనస్ 12గా రాసుకున్నట్లయితే మనకి 28 - θ/θ - 12 = 15/16గా ఏర్పడింది. దీన్ని సూక్ష్మీకరించగా తీటా ఈక్వల్ టు 20.26 డిగ్రీ సెల్సియస్గా ఏర్పడడం.